This conference will now be recorded.
Welcome back to Live Talk with Dr. B. Hill. If we have any visitors today, you are more than welcome to ask us questions in the chat bar, and that's on the right-hand side of your screen. And you are more than welcome to do that, and Dr. B can answer questions. So, Dr. B?
Hi, everybody. How are you? Thank you, Chrissy. And we have Dr. Smith and we have Travis here today. And we want to welcome both of them and thank them for appearing with us and sharing all the information that they have that's available. And I believe they're planning a trip in the next 3 weeks back to Washington. All right, Dr. Smith.
Dr. B,
Travis
how
will
are
join
you
us
today?
very shortly.
And Dr. B, as you know, we live way out in the country, and I have to drive in town to get on the internet, to get on Wi-Fi. And I'm here at the public library in Loudoun County, and there is a dog parked next to us, and I have my dogs with me. So if you suddenly hear barking,
We'll know exactly why, correct? Great, Travis, you have some real trouble there.
I had
We
to
have
come
no
inside.
sound.
It wasn't reaching for the car. I don't know why.
Oh,
you were
okay.
coming
Well,
in
we
good.
can hear you now.
You
You were
have no
coming in
sound?
the car.
Oh, we can hear you now.
Yeah, it cut off in the car and then made me reconnect it to the Wi-Fi. I don't know why.
Isn't that something? That's really something. Well, anyway,
This won't
so
be a
here we
problem after tomorrow.
all right. Well, Dr. Smith, you want to start off with our wonderful scale that shows how much damage has been done with the opioids?
Well, Dr. B, what I think we should do is, as we're moving into a phase where people are going to begin hearing about it, and um, um, this will be the first time hearing this science, this data. Uh, let's start off each day with two slides, just to make sure we put them up there. The first slide is the DNA slide, that the one that's right there, the blue and red column. Uh, And then the second slide that we want to show will be the catecholamines of the people while they were in withdrawal. But let's take a moment and look at this slide right here. And Travis, just so everybody knows, uh, the three of us on this screen right here are all three of us are we share a common background in that we were all part of this clinical trial of which you see the DNA results there. I wrote the clinical trial, the approval from the IRB. Dr. B conducted this portion of the clinical trial. And Travis, you were one of the participants in this clinical trial. Is that not correct?
Yes, sir. That's correct.
And as a participant, your privacy is extremely important in research. But you felt so compelled that you have come forward to discuss your results in the clinical trial. And Travis, what you're looking at right there, just so the audience knows, that is a representation of a gene called the OPRM1 gene. OPRM1, opioid receptor mu, opioid receptor mu1. And as the providers know, the mu opioid receptor is the primary opioid receptor. It's the main opioid receptor. This is a very old and primitive receptor in the nervous system. It's been around for hundreds of millions of years. You can find it all over nature. Uh, and you have to hit mute until you speak.
What's that?
I think
Hit
you're going to have
mute until
to
it's your
mute.
turn to speak. If you want to say something,
Do I want to say something?
hit mute.
Okay.
Yeah, we were getting a little background noise there, Travis, and it was coming through pretty loud. Um, so this is the OPRM1 gene. This is the gene that uh, uh, is used by the body to manufacture the main primary opioid receptor. This is a very important receptor to the body. Okay, this is an old and primitive receptor. This receptor is embedded in systems in the body that are old and ancient and fundamental to life. This is not a receptor that you want to be messing with. This is not a gene that you want to be messing with. You're looking at part of how life itself functions. This is the gene for the opioid receptor, the main opioid receptor, the mu opioid receptor. And Travis, as you can see there at the bottom, there are little blue and red columns side by side. Everywhere you see a blue and red column in our clinical trial, what we did was we compared the DNA of people who had never taken opioids, opioid naive, they are there in the blue, and we compared that to the DNA of people who were opioid dependent. In other words, when they tried to stop taking the opioids, they became sick. And Travis, as you can clearly see there are multiple sites spread out all over this gene where the damage, the methylation, the addition of a methyl group to a CPG island, the poisoning has occurred on multiple locations throughout that gene. And Travis, I think the first question to ask is given the fact that you see the genetic damage spread out all over multiple locations throughout the gene into and including the promoter region, Travis, would it be reasonable to expect that because of this level of genetic damage, this level of methylation, this level of what is known as gene silencing, in other words, the methylation turns off the area of the DNA beneath it, because of this widespread gene silencing, this widespread damage, this widespread poisoning, would one expect that this gene would now be able to manufacture a normal opioid receptor? Or would it be more likely that this gene is going to produce an abnormal opioid receptor?
Sir, my opinion is it's going to be it's going to produce an abnormal receptor, not a normal one.
And since and that's just common sense. You do this much damage to an area of DNA, you're going to have some impact, have some results, and you're even poisoning here inside of the promoter region, which the listener can go to Google, look up the promoter region, how methylation is within the promoter region of the gene. So, Travis, if this gene, and this is your DNA in here also, this is what your DNA looks like. If this gene is now damaged and this receptor is now damaged, it's not a surprise that this receptor would behave abnormally. And what we believe is happening is that once the damage reaches the threshold, reaches the level you're looking at right here on the screen, once the individual is this damaged by the opioids, that when they attempt opioid abstinence, in other words, when they try to stop taking the opioids, they lose control of a part of their nervous system. And that specifically the part of their nervous system that they lose control of is the part of the nervous system that controls the organs. Technically, that's the autonomic nervous system. But Travis, when you experience withdrawal and you allowed yourself to go into withdrawal for this clinical trial, you volunteered for 3 days of withdrawal so we could draw your blood. But Travis, is that what it felt like? Did it feel like that you had lost control of multiple organs in your body, the sweat glands, the hair follicles, your heart, your bowels? Is that what it felt like? We may have lost Travis there.
No, you didn't lose me. I'm here. Can you repeat the question one more time? I apologize.
I can. We believe that when the receptor is this damaged, and when the receptor is this abnormal, that the what happens when people go into opioid withdrawal, what happens when people are opioid abstinent, is they lose control of the nerves that takes care of the organs. And when they lose control of the nerves that go to the organs and lose control of the organs, that's what people are feeling and experiencing with opioid withdrawal. So the question was, you having gone through opioid withdrawal before, do those words make sense? Does it feel like you've lost control of multiple areas of your body, the sweat glands, your heart, your bowels, the hair follicles? Does that make sense?
Yes, that makes a lot of sense to me, Doug. I mean, Dr. Smith, it makes a lot of sense to me. When you're in withdrawal and you get very, very sick, you lose control of everything. I mean, just a few things that you spoke of is an understatement. I mean, like I said before, it's something that you can't really explain. But someone who's on opioids that's been through it, they'll know exactly what I'm talking about. But it's near death experience. It literally is to me a near death experience. I mean, you lose control over everything. I mean, you have no control.
Your eyes were watering, correct?
Yes, sir. My eyes, my nose was watering very, very badly. I mean, just pouring, just coming down, coming down, coming down. My my stomach was upset. I couldn't get out of bed. I was having aches and pains. I mean, it was, you name it, I had it. I mean, I felt like I had the flu times 1,000. I mean, it was bad.
Would that be consistent with a loss of control of the nerves going into the various organ systems?
Yes, I would believe it would be.
One of the symptoms you had was yawning, if I'm not mistaken.
Yeah, you do yawn. You do yawn because you feel tired. You feel, and so it makes you yawn. I don't know how to explain that either, but you just feel real tired, no energy, and you just feel sick.
And we're putting forth that with normal DNA, with normal anatomy, with normal function, Mother Nature has seen to it that it is almost impossible for an individual to experience a rapid heart rate, poor sweat, dilated pupils, and be yawning at the same time. Those are two separate systems that are kept apart and away from each other in the body. One system is the fight or flight system, one system is the rest and digest system. And Mother Nature has spent hundreds of millions of years making sure that both those systems were not activated at the same time. By the way, Travis, just so you know, when you do sleep, there is a secretion from your nose, the nasal mucosa, to keep your nose moist, and there are secretions from your eyes, the mucosal surface of the eyelids, to keep your eyes moist so they don't dry out while you're sleeping. So watery eyes and runny noses and yawning, they all are controlled. They all go together with sleep. Uh, so if we have these two systems in the body, the rest and digest and the uh, uh, fight or flight, Travis, you can kind of see how the symptoms that you had mostly fell into one of those two categories. The pouring sweat is part of the fight or flight. The hair standing on end is part of fight or flight. The feeling anxious and agitated is part of fight or flight. The watery eyes, the runny nose, the yawning, those are part of the rest and digest. Obviously, the bowel symptoms are part of the rest and digest. And again, it's just common sense to look at this series of symptoms and go, oh wow, this is a dysfunction in the nervous system. And instead, the psychiatrists have looked at that and said, oh no, they're just craving opioids. And more technically, what happened, Travis, when you got really sick, you wanted an opioid so you would stop this horror. And if you had an opioid, you would take it. And that, even if you had to steal something and go to the street and get it, that's what people did. And when the psychiatrist saw that behavior, that's what the psychiatrist pointed at and said, oh, they're opioid addicts. Okay. When in reality, what was happening with these people was they didn't have a proper diagnosis. They didn't have a proper treatment. They felt like they were going to die. We believe many of them did. And they were just taking an opioid to try and survive, literally survive. And we feel that's where the psychiatrists made their mistake. They looked at the behavior. Oh, wow, they're taking opioids after opioid after opioid. And you got to admit, some of these people were taking 20, 30 pills in a day. Okay. And the psychiatrist looked at that and said, oh, wow, they are opioid addicts and they're trying to get high. Whereas, Travis, if we're not, what you're saying is these people weren't getting high at all. They were sick and they were just trying to survive. Can you tell us a little about that?
Okay, so Dr. Smith, basically, when you start taking opioids, the longer you take them, the more that you need to actually not get sick. And what I mean by that is, say your doctor starts you off on 2 a day. So you're supposed to take 1 in the morning, 1 at night, just hypothetically speaking. So you start taking those 2 a day for, I don't know, a couple months, if that, maybe a month. Well, after that month, you'll realize that, okay, I'm taking the 2 a day, but I'm still getting really sick and I'm not feeling normal like myself. So let me go ahead and take, 4 a day to see if I can feel like I used to so I can feel normal again. You start taking the 4 a day. And then before you know it, the 4 a day is not helping you not get sick. You're still getting sick. So it's almost like your body becomes immune to the dosage that you're taking, and you keep having to take more and more and more and more and more just not to be sick. It was never about getting high. Never about getting high. You could be terribly sick and only have one pill, and you could take that one pill and it'll help your sickness a little bit, but you're going to need more than one opioid pill to not be sick. Like you're probably going to need 2 or 3, depending on how tolerant your body is. But it almost seemed like to me that the more I took, the more I needed to actually feel normal and to feel not sick again. It was really ridiculous. I mean, it was almost like a game of cat and mouse. But I mean, I don't know how to explain it, but it even taking it as the bottle's prescribed, before you know it, you will need more just not to be sick. But you never wake up in the morning thinking, okay, time to get high, guys. Good morning. Time to get high. You're not thinking like that. You're thinking, all right, it's the morning time. I got to make sure I have my medication set up for today because I can't be sick. I got to go to work. I got to do this. I got to do that. I cannot be sick. So that's really all you focus on, is not being sick. Because like I've said in previous videos, once you've been sick one time, you'll never be sick again. You will do whatever it takes never to go through that again. It only takes the one time of going through it, and it will scare you to an end where you will be willing to do anything not to go through that again. I'll just put it to you that way. It's that bad. The sickness is that bad. It will scare you into to doing whatever it takes not to ever get that sick again. I mean, that's the only way I can explain it. I mean, it's just bad.
By the way, Travis, you mentioned the term tolerance. Tolerance to the increase. Part of our theory is that the reason tolerance exists is that as the DNA damage changes the opioid receptor, the receptor needs a higher concentration of opioids to do what it normally does. And that, again, I think we're just talking about common sense there. Chrissy, if we could jump ahead to the catecholamine slide. Travis, you volunteered to go into 3 days of opioid withdrawal and then have your blood drawn. You were part of a group that was the first group in the history of the world to have their blood drawn while they were in opioid withdrawal, and specifically for blood levels of what we in the medical field know as the catecholamines, norepinephrine, epinephrine, and dopamine, and what the layperson would know as adrenaline. And Travis, right there on the screen, you can see the results of the 15 participants of whom we drew blood from them while they were in opioid withdrawal. Based upon the levels that you see on the screen right there, we decided that because these levels we judged to be incompatible with life, we called an emergency halt to the study. But Travis, if I'm not mistaken, you're number 700 there on the screen, and you show both an elevated epinephrine and norepinephrine level. And Travis, what we're saying here is that we're using this as evidence, scientific evidence, that indeed your body did lose control of the organs. Your body did lose control of the sweat glands, the hair follicles, the mucosal cells of the nose and eyes, the heart, the bowels, and that one of the organs that your body lost control of is the adrenal glands. And by losing control of the adrenal glands, you get these massive levels of adrenaline in the blood. And that while it is uncomfortable to lose control of your sweat glands, and it's distressing to lose control of your bowels, it is deadly and dangerous to lose control of your adrenal glands, because adrenaline will kill you. So, Travis, you experienced adrenaline toxicity. Okay, you're quite frankly the only person I've ever known in my entire medical career who experienced this level of adrenaline toxicity for this long. Travis, what that means is I can't go to the literature and learn what people have said that this feels like. Okay, That type of knowledge doesn't exist in the medical community. Okay, you're one of the first people in the history of the world who can describe what 3 days of adrenaline toxicity feels like. So as more and more providers are finding our sessions, are finding these recordings, and feel free to join us live, Travis, for these doctors and physicians assistants and nurse practitioners and even the other patients, can you take your time and just walk us through what it feels like to experience this level of adrenaline toxicity for as long as you did?
Um, this is another one that's hard to explain because you're in the middle of withdrawing, so you're feeling sick, you're feeling all those symptoms, but then at the same time, it's like a never-ending. I don't know what the best word would be. A never-ending panic attack, maybe. Maybe that would be a good word. I'm not sure, but it was literally like a never-ending, just. I mean, you could be just sitting there on the couch, not doing nothing, and your heart is beating out of your chest.
We
Can,
had some technical
can you hear me?
difficulties.
Can you hear
Yeah,
me?
No, we couldn't.
yeah,
I'm
yeah.
sorry about that. So basically, you could be sitting on your couch doing nothing, and it's like a never-ending panic attack. Your heart's just beating out of your chest. I mean, you feel like you ran like a mile run at your school or something. But it's also like it's not comfortable. Like, so you're sick, you're going through withdrawal, but then it's like your mind's racing, your body's racing, your heart's racing. It's almost like you're an autopilot. You're there, but you're not there. It's very, very hard to explain what I was going through for those 3 days, because at the same time I was very, very sick as well. So it was like up, down, up, down, up, down, up, down. I mean, it was a wild roller coaster, to say the least. It was an up and down, never-ending panic attack roller coaster. It was a nightmare. It was a literal nightmare. I mean, if you could, if you could have a picture for the word nightmare, those 3 days would be on it. I mean, it was very bad.
Travis, I meant to ask you this before, but there's a medical term that's used associated with a very rare type of tumor that occurs predominantly in the adrenal gland. It can occur other places, but predominantly in the adrenal gland. The tumor is the pheochromocytoma. Let's not worry about the name of the tumor. But it will have intermittent spurts of elevated catecholamines, elevated epinephrine level, and what these people with this tumor have described is a sense of what is called impending doom, that they feel like something really bad is about to happen.
Yep, yep, I could agree with that.
Travis, what does that feel like? Impending doom.
I mean, it's scary. I mean, like I told you, when my heart started beating out of my chest when I was on the couch just watching TV, you do have thoughts that cross your mind, like, oh man, I'm gonna die of a heart attack, or what's going on, and is my heart okay? Like, I mean, you do, like, but that's why I meant by panic attack. Like, and maybe that was the wrong word, but you're freaking out. Like, that's what I meant by panic attack. Like, you're literally freaking out about everything. I mean, it's never ending. Your heart is just do 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 do, and then you're still sick. So you'll be like that for 3 minutes, and then you'll all of a sudden you'll be deadly sick again, and then the adrenaline will start again, and you're just, I mean, it's up down up down up down. It's a scary feeling. It really is.
Travis, now that you've had your DNA run and you've literally seen the results of your DNA, and now that you've had your blood work done while you were in opioid withdrawal, and Travis, you're one of the few people in the history of the world who has ever had both their DNA analyzed and their blood work analyzed for catecholamine, and kind of seen the whole picture. Travis, now that you've seen the results of the DNA, now that you've seen your blood work during withdrawal, does it make a little more sense what happened to you?
Yeah, everything, like I told you earlier, well, on previous videos, like when I saw my catecholamines and I saw the results of my blood and my DNA, and you know, the evidence was, you know, brought forth to me, and I got to read everything and research it. It was almost like a light bulb went off in my head. It was just automatically, it just like, man, this is what I've been missing. Like, this makes sense to me. This makes perfect sense. To me, it's perfect common sense. You know, I'm not a scientist, I'm not a doctor, but if you actually, you know, do your due diligence and you research everything and look at the catecholamines and you see the DNA results, you see everything. It's 1 + 1 = 2. It was all common sense to me at that point. Like, it makes 100%. It makes better sense than what they're trying to tell me, that I'm an addict, that mentally something's wrong with me, you know, that I have a mental disorder. I'm not going for that. But this research and this, you know, this proof that we have through the Smith test, you know, this makes sense to me. I'm willing to back that up. You know, as someone who was on opioids in the past, this feels right to me. It makes more sense. Everything else that they're saying doesn't make sense to me. It makes me feel like I'm the bad guy, like I did something wrong when, you know, I never did anything but get sick and end up in a doctor's office, and then they wrote me prescriptions. And the next thing I know, my life is spiraling out of control and I have no control over myself. And I didn't ask for that. I didn't sign up for that. If they would have told me, you know, beforehand what could possibly happen to my DNA, you know, what could happen to my body, what could happen to my life, you know, I would have never taken them. I would have been like, no, thank you. I'm good. I'll try something else. I know myself. I never would have put myself in that position, you know, because I feel like I'm a strong person and I never want anything to control me. That's just how I've always been. I don't want anybody or anything to control me. And, you know, opioids took over. I mean, it literally took over within, you know, no time at all with me taking them. And if I was warned prior, you know, I would have never got on them. I would have never taken them, period. I would have walked away. I would have found a different way to do it.
What you're talking about there, Travis, is a process that we in medicine call informed consent. In other words, we as providers have an obligation to our patients to tell them everything that we know, and to tell them the risk and the benefits of a medication. And what you're saying there, Travis, is nobody warned you that the opioids could damage your DNA, although the scientific evidence goes back almost 15 years. You can go back to Nielsen in 2009, Shorbov in 2011, Walkman 2014, Walkman 2018, Sandoval Sierra 2020. The scientific evidence has been there. So there is absolutely no excuse since 2009, absolutely no excuse for people not to have been warned. There is no excuse that informed consent has not been part of the opioid prescribing process since 2009, and a lot of that I personally put the responsibility for that directly on the FDA and directly on Dr. Rigoberto Roca, the division head of the FDA division on anesthesiology, addiction medicine, and pain medicine. They really dropped the ball.
Yeah, I agree with you, Dr. Smith. They really did. I mean, they dropped the ball big time because, you know, millions of people have died from this, and there's millions more that are still suffering today, and probably millions more each day that are getting on these opioids. And, you know, it has to be stopped. It has to be.
There's Chrissy.
Well, thank you so much for joining us today. Absolutely a lot of information. So we thank you for being here, and thank you for joining us with Live Talk every Monday through Thursday, 12:30 to 1 with Dr. B. Hill. And thank you.
Thank you, everybody,